Now let's make our decoder behave more like a real decoder. All of the code from our world's simplest decoder is there. We have a decoder name, putGet. We have a decoder ID. But the field statement has changed. The field name is now opcode. An opcode, or event code, or function code is common to nearly all protocols. So it is common in protocol decoders to read the protocol opcode and take some action based on that code. In our more useful decoder, the size method is now set to fixed 1 byte, which is consistent with reading an opcode. And where the world's simplest decoder method used the string of hex, it now references a table. Let's take a look at this table. The table method is very powerful. It says that we take the value of this field and look up that value in a table and display the string associated with that value. So, if the resulting value of the field statement is a 1, we display get. But there is more to the table. First of all, there are 2 strings. The first string is displayed in the frame display decoder pane, and the second string is displayed in the summary pane. The summary pane is in a table format, and the column width may be limited. So sometimes we display the string in an abbreviated or truncated form. Let's take a look at what else is in the table. Skipping over that 0, this is for advanced users, we see gput and gget. These are like function calls. In decoder script, we call functions groups. Remember that we said we were going to take some action based upon the value of the opcode. In this case, we are going to branch based upon the value from the field opcode using the same table T opcodes that was used in the field statement. For example, if the value of opcode is 1, when we get to the branch statement, it will use the table T opcodes and the opcode value to look up a group that will execute a function. Groups are very basic decoder script constructs and can be thought of as functions or methods. In our more useful decoder, the groups contain just field statements. So now we have the basics of just about every decoder. It has a name and a decoder ID. It has a mainline routine where we read some sort of opcode which we translate into something human readable. Then we do different things based upon the value of that opcode. Looking at how the decoder works with the tables and the groups, we see a path from the decoder that has extracted the first byte from the frame protocol to a table that contains all of the expected codes that should be in the first byte of our protocol. The table provides a path to the groups, that is our functions, where specific actions are performed. Let's focus on just the field statement of the gput group. We're going to take a look at what happens when we execute each part of the statement. Field says that we are creating a field. PutData instructs the compiler to create a 64-bit register named PutData. This will be our working register. ToEndOfLayer tells the compiler to load the data to our register. If ToEndOfLayer is greater than 64 bits, the data is not loaded to the register. String of hex tells the computer how to format the output for display in the frame display. Formats like decimal and hex would require a field with a length less than 64 bits. String formats like string of ASCII and string of hex will take the data directly from the frame and bypass the register. Finally, there's the label PutData. This is plain text that will identify your field in the frame display decoder pane. In our more useful decoder, the field statement in gput will only execute if the protocol opcode equals 0, and the field statement in gget will only execute if the protocol opcode equals 1. However, other decoder fields could use these groups for other purposes because they are a global function. To see our more useful decoder in action, we follow the procedures from a previous video by adding the decoder to My Decoder directory in the public folder, Frontline Test Equipment. And in the Frontline software, we use the protocol stack option to add the decoder to a protocol stack. When this is done, we selected the stack and begin analyzing the captured data. Here we see the Frontline Protocol Analyzer software with the new put-get decoder in action. The put-get protocol tab is visible, and we have included in the summary pane the decoder opcode display as well as the put data and get data display strings. Clicking on the frame shows the decode in the decoder pane. Here is the opcode with the expected get displayed. If you click on the decoder pane opcode field, you'll see the actual opcode highlighted in the event pane, and as expected, it is hex 01. Clicking on the get data field created in the get group, you see the hex string output from the field statement. You can verify the decoder actions by clicking on any of the displayed frames. Here we see the results of the decoder detecting a defined put opcode. What this video has shown is the value of tables to store lists of expected protocol values, and for those tables to provide links to groups acting as functions to perform specific actions. Tables and groups provide significant power to the decoder executable sections. In the next video, we examine a variety of field statement formats that extend their power and functionality.